Building on our previous talk about cross-validation, let us dive deeper into data splitting strategy. Hello, machine learning students. Welcome to our deep dive. Most tutorials show you how to split data, but skip the strategic reason for the three-way split. In this video, we reveal the secret of the practice kitchen. Imagine your training data is a practice kitchen. This is where your model, our apprentice chef, learns the basic patterns of the ingredients. Once our apprentice chef has practiced, we need feedback. This is the role of the validation set, which acts like a head chef. The head chef tastes the dish and suggests adjustments, like adding more salt. In machine learning, we call these adjustments hyperparameters. We use the validation set to tune our model, picking the best version of the recipe before it ever leaves the kitchen for the public to see. Finally, we have the test set, representing the restaurant critic. The critic only tastes the final dish once. They have never seen the practice kitchen or the head chef's notes. This ensures their review is completely unbiased. In our strategy, the test set is locked away until the very end. It provides the final judgment on how well our model performs on completely new, unseen information, telling us if we are ready. Visualizing the flow of data helps us understand the pipeline. Imagine ingredients moving through three distinct stations. First, the large training station where the bulk of the work happens. Then, a smaller validation station for refinement. Finally, a single plate reaches the test station for evaluation. This linear progression ensures that information from the future does not leak into the past. A common mistake is memorizing a single person's taste instead of learning to cook well. This is overfitting. By comparing the apprentice's performance in the practice kitchen against the head chef's feedback, we can see if they are just memorizing. If the training score is high, but the validation score is low, our chef is overfitting. We use these separate splits to find the sweet spot where the model generalizes perfectly. To wrap up our journey, remember the standard proportions for your data split. Usually, we dedicate 70% to training, 15% to validation, and 15% for the final test. This balance ensures the chef has enough practice, while the head chef and critic have enough data to give a reliable score. By following this strategy, you ensure your models are robust, reliable, and ready for the most demanding real-world environments. Subscribe for more deep dives into data splitting strategy.